Welcome back, Math 098. We're going to continue on with simplifying rational expressions. And just as a heads up, sometimes it's easier to just rewrite the problem and understanding the commutative property. So I know this probably seems weird, but I'm going to add a little piece to this where I'm writing like 1 times the quantity of something and 1 times the quantity of something. Because earlier, if you watched the first video, I talked about that you can only cancel out with multiplication. So yes, everything is being multiplied. It's just multiplied by 1. So that's why everything cancels out on this one. To equal 1 over 1 is just 1. So this is where there's that little caveat in here that this expression, this rational expression, reduces to just y equals 1 as long as x does not equal -3. Because if x equals -3, you'd have 0 divided by 0, which is not technically 1. So you have to be careful there. And the other thing I wanted to mention is I've seen students in the past will try to cancel this out to 1 by saying like x over x is 1 and 3 over 3 is 1. That's not how this works. Let me explain why that's not. And it kind of boils down to my example from my first video. Let's say I had like 2 plus 2 over 2 plus 3. If you were to just cancel out the x's that way, then you'd be left with 2/3, which is wrong. Because 2 plus 2 is 4, and 2 plus 3 is 5. Well, 4/5 is 0.8, and 2/3 is 0.6 repeating. So there's a big difference with that. So please, please, please only cancel things out with multiplication. And then this last one on this slide, the way I would do this is greatest common factor of the numerator to make it -1. That way the negative x turns into a positive x, and the positive 3 turns into a -3. And if you don't believe me that that's the same as the numerator, distribute that -1, and then you would get -x plus 3, which is the same thing. And the whole point of doing that is now we do have a multiplication problem where we can cancel out the x minus 3's, and you're left with just -1 on here. Again, you don't have to write this, that x cannot equal 3 in the problem, otherwise you'd be dividing by 0. But that is extra. It's nice. It's good practice. I didn't mean to write over that value, but there you have it. So as we move forward, there's a lot of simplifying. This is why you go through the whole polynomial unit and just do one problem at a time. So for instance, start with the numerator by saying, okay, we'll factor out a 5. So that's 4 minus x squared. Oh, well, that's a difference of squares. So you still have that 5 in front, but then your difference of squares will tell you it's 2 plus x, 2 minus x. And it might take you a while to do this. I've been teaching math for years, probably longer than you guys have been doing math. So I kind of have an advantage at that. So in this problem, kind of go through, and maybe I'll skip that middle step because once you factor, the answer is pretty obvious, of 3 minus 2, because 3 times -2 gives you -6, and 3 minus 2 gives me +1. So, whoops, I don't know why that just happened. What I have is x plus 3, x minus 2, which is almost the same as this. But we can do the same trick that we did in the previous problem, where you can just factor out a negative on top or bottom, and just one of them. You don't want to, can't do it at both. So that makes that a positive x minus 2. And then in the denominator, leave that x minus 2 alone. That way you can cancel these out. And instead of me rewriting it, I'll just put a box around this answer. This is your correct answer. Simplified. Now, again, a better math teacher would sit there down and say, well, make sure you say x can't be -3 or +2, because then the denominator would equal 0 there. But that's a little bit in the future of math problems that we'll need to investigate. So moving forward with the next one, there's a sum of cubes. So everything you learned in chapter 5, it's coming back. So notice that this is 4 cubed. So as a reminder, we have x cubed plus 4 cubed is the same thing as that numerator. And you can rewrite the denominator as x plus 4. So the whole point of doing that is then to do the sum of cubes, which you just write x plus 4, and then remember it's x squared, it's the opposite sign here, 4 times x, and then always positive. 4 squared is 16 over x plus 4. Notice the multiplication. That way you can cancel those pieces out. And this is your final answer, x squared minus 4x plus 16. And maybe it's a good time to remind you that you can check your answer using technology, graph and calculator. So let me do that real quick. So notice I just typed into the graph the original problem. I think I switched to 4 plus x, but it's commutative property, so we're good. And what you'll notice is my simplified answer is falling directly on top of the original problem. Now there is that little caveat I mentioned about before, that at x equals -4, this one has a defined value and this one does not. And that's why a better math teacher would mention that. Let me just show you with a table. If I were to give you x equals -4 here, we have an undefined value, but on this one, if I put x equals -4, we actually get a value. So it's a little bit more advanced, but that's why I'm mentioning it, as a better math teacher would mention it. So moving ahead, hopefully I'm not going too fast, but if I am, feel free to pause the video and write down any questions you may have. So this is just greatest common factor in the numerator. Well, if you look at the denominator, then there's a little bit more work to do. There's 4 terms, so you have to group. Well, greatest common factor, maybe I'll just do this off to the side. In the first 2 terms is x squared, and you'd be left with x minus 3, and then plus the greatest common factor with that one is 2. You're left with x minus 3. So in the denominator, the x minus 3 is shared, and then the leftovers, x squared plus 2, can be canceled out because of the multiplication. Cancel those out. And so your final answer, I'll go ahead and rewrite it, it's just 5 over x minus 3. And you can use Desmos to double check you have the right answer. And since I mentioned it before, I might as well mention it here as well. The only undefined value is x equals 3, because this little piece right here can never be 0. X squared is always a non-negative number, and when you add 2 to it, you always get a positive. So this can never equal 0. So that's why there's only one undefined value. Yeah, let's keep moving forward. As a reminder, if at any point you feel like pausing and trying to figure things out yourself, go for it. As I look at the next one, what I would do is still do the greatest common factor, but you may need a reminder from ages ago that when you multiply, you just do numerator with numerator, but I would still factor where possible. So if I were looking at this piece, this 2n minus 4, I would bring the 2 in front and factor out. So it becomes n minus 2. And there's nothing to do with that 1 plus 3n. If anything, you could just rewrite it as 3n plus 1, which I'm only doing because I'm looking at this denominator over here. So if I look at like I said, the denominator, I can't do anything with that 2, can't do anything with that n, but you can notice that you can already cancel out that greatest common factor 2 that we had earlier. So then looking at the rest, again, I'm a big fan of guessing and checking because there's only way to get 3n squared, and that's 3n and n. There's only one way to get 1, that's 1 times 1. And just sort of by using the logic here, it would make sense that this is 3n plus 1 and this is n minus 1, but we can double check that that's true by foiling. I would have negative 3n plus 1n, which is negative 2n, so it is true. And the reason why I talked about logic is because you want to cancel things out. But you do want to double check that it's right because, you know, your teacher does make mistakes. So your best answer is just n minus 2 on top. If you want to put parentheses, you can. And then n times n minus 1. I've also seen teachers will distribute at the end, which I do not expect you to do that. So moving forward, I realize that I am going pretty fast, but I think you can handle it. Again, when you multiply with a fraction, you just multiply straight across. Now, I might rewrite that 6x squared in front. Probably don't have to, but you could. And then I would rewrite that numerator because 8 is the same thing as 2 cubed, so that's your difference of cubes. X minus 2, x squared. You change the sign so it's plus 2 times x, and then always positive. 2 squared is 4. And then in the denominator, I have two things. I have the greatest common factor, so I would factor out a negative 6, just because I want to see that this would be x minus 2 inside. And then this, oh, I don't think this is factorable, so let's just leave it alone. But as I'm doing all of this work, again, look for your multiplications. So 6 divided by 6 will cancel. All of these are being multiplied, by the way. All of these are multiplied. X minus 2's can cancel, and the x squared plus 2x plus 4 can cancel. So you are left with only negative, I almost forgot that, x squared. So this very, very complicated answer or expression here simplifies to negative x squared. Very, very easy. Yeah, we take complicated things and make them easier. Last year when I was teaching this, I'm not a big fan of this phrase, by the way, but everybody said it, so I might as well just join with what other people say. Keep, switch, flip. The reason why I'm not a big fan of this is just memorizing how to divide fractions. I don't think it actually helps anybody understand the fractions. But if I just accept that to be true, then we can rewrite this problem as multiplication. And notice that I'm going to flip this thing, 3 minus y. And then in the denominator, I would have 3y squared minus 27, 27, and then times that 42. Now again, I would do two steps at once to make this problem easier. I would factor at the same time that I'm doing this. For instance, as I'm looking at this problem, I'm looking on top and bottom that, 6 and 42, well, 6 goes into 42 7 times. And then in the numerator as well, I'd be looking at that and saying, oh, well, this y is negative and this y is positive, so I might rewrite this problem as negative y cubed, so I can make this y positive and this positive 3 negative. And then at the same time, I can factor out a 3 in the denominator, times this 7 gives me 21. And then I'd have y squared minus 9. And I don't know if you noticed, but maybe at the same time I could rewrite this y squared minus 9 as y plus 3, y minus 3. That way I can cancel out the y minus 3's. And the best answer, I know I'm all over the place here, so if you are struggling at all with this example, feel free to reach out to me and we can do this. But I'm close to the end of the time and I don't want to rush through this last one. So it might be a good thing that I repeat myself with the keep, switch, flip. And again, a lot of students just memorize that. So at this stage of high school, though, I'm not going to, if anybody wants to know, I can explain why keep, switch, flip is true. So keep the first fraction the same, switch the division to multiplication, and flip this last one. And I'll see you in the third video.